Let's learn about digital signatures in relation to application security. Digital signature uses the mechanism of public key cryptograph technology to deliver the private key encrypted hash value of the message. The receiver decrypts it with the sender's public key, and cryptograph technology is then used to implement sender authentication and non-repudiation functions, as well as guarantee the integrity of the message. Let's look into the digital signature process. First, the sender creates a message digest, a fixed-length string, by applying a hash algorithm to the message to be sent. Then, it encrypts the created message digest, using its own private key to create a digital signature. The message and digital signature are then sent to the receiver. Then, the receiver decrypts the received digital signature using the sender's public key, thus extracting the message digest created by the sender. It then applies the same hash algorithm of the sender to the received message, creating a new message digest. By comparing the message digest it created with one from the sender, it determines the proper sender with digital signature in the two are identical. Next, let's take a look at public key infrastructure, which is an infrastructure used to manage public keys. It refers to the infrastructure for the safe distribution of encryption and decryption keys and certificates, which provide information security service. In other words, in various applied areas that require safe communication, such as information system security and e-commerce, this can be seen as a network structure of objects that builds and provides policies, means, tools, etc. If we look into the structure, we can see that PKI is divided into Policy Approving Authority, Policy Certification Authority, Certification Authority, Registration Authority, and Certificates. So, what are the roles of each element? First, the Ministry of the Interior creates and plans the policies and processes used throughout PKIs. Establishes detailed policies for policies approved by the Policy Approval Authority. Certification authorities issue public key certificates for users and manage the list of discarded certificates. Certification agencies, such as banks and securities, serve as an agent or accepts registration applications for certificates. The certificates issued in accordance with the process follow the X.509 version 3 standard, which then act as an electronic file to prove the relationship between the verification key of the digital signature and the owner. Next, let's learn about how the public key infrastructure operates. When a user applies for an authorization certificate issuance after completing the application to join and confirms the identity check at its RA branch, the RA sends a request for information about the issuance registration to the CA. The CA issues a certification signed with its private key, shares it with the directory server, and delivers this information to a user through RA. The user saves the issued certificate on a hard drive of a PC or a portable disk to use it for financial transactions or e-commerce. In this case, financial institutions proceed with the verification process for the certificate through the Certificate Authority. Next, let's learn about digital signature and the encryption processing procedure of PKI. Using the basic technology we learned in advance regarding encryption technology, we will take a look at the process from the sender and receiver side. First, the sender creates a message digest by applying a hash algorithm to the original text of the message. Then, an asymmetric key encryption algorithm is applied to the message digest to encrypt the sender's private key. This is the digital signature process. Next, a symmetric key encryption algorithm is applied to the original text of the message to encrypt it into a session key, which is a one-time secret key that is only valid while the session is being maintained. Lastly, the session key used for encryption is sent, encrypted with the receiver's public key, which is called a digital envelope. Next, let's take a look at the process from the receiver side, which is where the digital signature is decrypted with the sender's public key and restores the message digest. Then, the encrypted session key is decrypted with the receiver's private key, thus enabling the session key to be extracted. Then, using the extracted session key, the encrypted original text is decrypted. Thus, the message digest is created by applying a hash algorithm to the decrypted original text. This is a procedure that checks whether the two message digests match by comparing the extracted message digest and the original message digest. Let's go into PKI certificates in more detail. Certificates conform with the X.509 standard and are issued by publicly authenticated authorities. The NPKI certificate is used for financial transactions and e-commerce for the general public. On the other hand, the GPKI certificate is used in administration institutions for administrative purposes. The following is a screenshot of the NPKI certificate. Please check the contents included in the certificate by clicking on the button. Digital signature using certificates is widely used in various areas such as finance, corporate e-commerce, government civil services, real estate, medical, trade, etc., with legally binding force according to Article 3 of the Digital Signature Act. Please check the uses by clicking on each area. We will not be studying about the basic principle of the SSL protocol. SSL is a protocol developed by Kip Hickman of Netscape in 1994. Since SSL version 3.0, it has been standardized to be called TLS, and most web browsers currently support the SSL protocol. Because the SSL protocol operates between 4 to 7 layers, it can support various application programs. HTTP is the most widely used application program, and you can see HTTPS identified on a browser. To configure a safe internet environment, security protocols based on ActiveX is commonly used in Korea. Recently, though, with the gradual expansion of Open Web, which is based on web standardization, the standard SSL is being widely used to center the financial sector. Now, let's take a look at the structure of an SSL protocol. SSL is a protocol that operates between 4 to 7 layers and consists of handshake, change cipher spec, record and alert protocols. Please refer to the table for the details of each protocol. Next, let's learn about the operation process of SSL protocols. First, the client sends a hello message to the server to request for an SSL connection. The server then sends a hello message along with the server certificate and the server's public key as a response to the requested hello message from the client. Once the client verifies the server's certificate, it creates a session key, which will be used for encryption, encrypts it with the server's public key, and sends it to the server. Here, a signal is sent to send and exchange encrypted data using algorithms and keys defined through such security negotiations, which is called the Change Cipher Spec Protocol. Once the Change Cipher Spec Protocol is exchanged, The client and server exchange encrypted data according to the cipher spec that has gone through security negotiations. An SSL certificate must be installed in the web server to apply SSL. To do so, a private key has to first be created on the operating web server. Once a certificate signature request or CSR is filled out and requested to the certification authority, an SSL certificate is issued from the certification authority. Then, install the SSL certification on the web server and change the web server settings. If an SSL accelerator is used, it may be installed on the SSL accelerator. So, how can we check whether the SSL has been applied? You can simply know through the yellow lock found at the bottom of your web browser or through the https:// on the URL address screen. The security alert screen that appears when you move to another page is another indicator, and security authentication seals are also indicators of SSL application. Various computing tasks generated in the SSL handshake process leads to a massive load on the CPU, which is why we must be aware of a few aspects to be able to solve this problem. First is the SSL accelerator, a solution to solve the problem of excessive load on the CPU. One type can be installed on the server as a separate PCI card, and the other can be installed as an exclusive device. Recent SSL accelerators are provided as a separate function on the Web Accelerator and L4 switch, so you can simply purchase an SSL accelerator license. Also, once you apply the SSL, change the URL included in the connection URL and web application source into https://. Moreover, for static contents such as images, JavaScript, CSS, etc., using an SSL web server cache or caching using a web accelerator will improve the web application response speed caused by an SSL load. Now, we will take a look at the security vulnerabilities of application programs and its response measure. First, let's look at email security. Let's go into vulnerability in email security. Emails are vulnerable to sniffing attacks as they are sent as plain text. The contents of emails can be counterfeited and falsified, and the attacker can disguise itself as an authorized sender through spoofing. Emails are also vulnerable to spam mails, the spread of malware, and increased network load through relay function. Let's take a look at security methods to respond to such vulnerability in email security. First, use a mail client program to filter spam mails or set the mail server to not allow spam relay. Please refer to the fact that you have to apply policies of either opt-out, which is a method of rejecting mails afterward, or opt-in, which is for rejecting in advance. You can also use a class map or a policy map in the router, or virus wall, which is a type of application firewall or block malware. Moreover, you can encrypt and decrypt Internet emails. Use PGP, a security method that enables digital signatures in order to confirm the message integrity by checking the sender's identity. Or use SecureMIME, which provides security services such as authentication, message integrity, non-repudiation encryption, etc., to safely send and receive MIME for sending binary files through emails. Next, let's look into the vulnerabilities of Telnet security and its methods for security. What are the vulnerabilities of Telnet security? Telnet has no protection against network sniffing attacks, where user accounts and passwords are easily exposed, and also allows attacks that can extort root authority. Now, let's see how we can respond to such vulnerabilities in Telnet security. First is to use SSH version 2, which is a protocol that can supplement the vulnerability on sniffing attacks as the Telnet session is not encrypted. SSH version 2 sends encrypted sessions, thus providing a safe remote connection service. Using the following methods, you can prevent remote login with root authority. Now, let's take a look at the vulnerabilities and security methods of FTP security. What are the vulnerabilities of FTP security? FTP enables brute force or invert attacks on the password of user accounts, and attackers can obtain root authority using attack codes to take advantage of the vulnerabilities based on the FTP program type and version information. As attackers have access to all users, if a user has the authority to write, it is possible for attackers to insert malicious programs. Also, an attacker can obtain user account or password through network sniffing. Moreover, it is vulnerable to scanning attacks on network ports of other hosts via anonymous FTP servers. Let's see how we can respond to the vulnerabilities of FTP security. First, prohibit the use of FTP services if it is not necessary. If it is needed, use secure FTP. Also, prohibit the use of any unnecessary anonymous FTPs, and if it is needed, make sure you do not allow the authority to write. Moreover, maintain an updated version of the FTP where the vulnerabilities are removed, referring to the vendor's security recommendations. Like the following, locking the connection of unnecessary users by registering accounts that are not allowed to connect is also a way to maintain FTP security. Standard technologies that provide services such as XML documentation authentication, integrity, non-repudiation, access control, and encryption services include XML signature to create and verify digital signatures for XML documents. XML, encryption to support encryption and decryption of XML documents. XKMS, for managing XML-based keys. SAML, which provides authentication function to support SSO. And XACML standard, for implementing access control of XML documents.